Hi everyone, and welcome back to educator.com. I'm Dan Fullerton, and in this mini lesson we're going to go through page 1 of the A+ Physics worksheet on mass energy equivalence, and you can find that worksheet by clicking on the link down below the video. So take a few minutes, see if you can work through that, and then we'll check the answers together. All right, moving on to number 1. If a deuterium nucleus has a mass of 1.53 times 10 to the minus 3 universal mass units less than its components, this mass represents an energy of, well, it must have become an energy, so that's going to be 1.53 times 10 to the minus 3 universal mass units, and we want to convert that into mega electron volts. So I know that one atomic mass unit, universal mass unit, is 931 MeV. Our units will cancel out there, and I will come up with about 1.42 mega electron volts. Answer number 2. Number 2 here, the energy equivalent of 5 times 10 to the minus 3 kilograms is, well, to find the energy equivalent, E equals mc squared. Probably heard that one before. That's going to be 5 times 10 to the minus 3 kilograms times c, the speed of light in vacuum, 3 times 10 to the 8th meters per second, squared. Put all that into my calculator, and I come up with an answer of right around 4.5 times 10 to the 14 joules. Answer number 3. On to number 3. How much energy in mega electron volts is produced when 1/4 of a universal mass unit of matter is completely converted into energy? Well, we have 0.25 universal mass units, and we want to convert that into energy in mega electron volts. I know that one universal mass unit gives you 931 MeV, so I can treat this as a unit conversion problem. 0.25 times 931 is going to give me about 233 mega electron volts. Number 4. The energy equivalent of the rest mass of an electron is approximately, well, again, E equals mc squared, where our mass, the mass of an electron, is 9.11 times 10 to the minus 31 kilograms, times the speed of light, c, 3 times 10 to the 8th meters per second, squared, which implies then that the energy equivalent is going to be, when I put all that into my calculator, about 8.2 times 10 to the negative 14 joules. Answer number 2. Number 5. The energy produced by the complete conversion of 2 times 10 to the minus 5 kilograms of mass into energy is, well, E equals mc squared again, where our mass is 2 times 10 to the minus 5 kilograms, c, speed of light, 3 times 10 to the 8th meters per second, squared is going to give us an energy of right around 1.8 times 10 to the 12th joules, which is 1.8 terajoules. Answer number 1. Number 6. What is the minimum total energy released when an electron and its antiparticle, known as a positron, annihilate each other? Well, energy is mc squared again, where our mass is going to be 2 times the mass of an electron, because the antiparticle has the same mass but an opposite charge. So that'll be 2 times 9.11 times 10 to the minus 31 kilograms. Our mass times the speed of light in a vacuum, 3 times 10 to the 8th meters per second, squared, which comes out to be about 1.64 times 10 to the minus 13 joules. Answer number 1. Number 7. The energy required to separate the 3 protons and 4 neutrons in the nucleus of a lithium atom is 39.3 mega electron volts. Determine the mass equivalent of this energy in universal mass units. All right, so we have 39.3 mega electron volts, and we want to find out its mass equivalent. Well, we want mega electron volts to go away. We want universal mass units, and I know that one universal mass unit is equal to 931 MeV, so we're multiplying by 1 again. Our units make a ratio of 1, and I come up with, when I do this, 39.3 divided by 931 is right around 0.0422 universal mass units. Number 8. Which graph best represents the relationship between energy and mass when matter is converted into energy? Well, if E equals mc squared, and our variables are E and m, well, c squared is just a constant, so it looks like we've got a linear relationship between mass and energy. That's going to be that direct relationship, number 1. Number 9, the total conversion of 1 kilogram of the sun's mass into energy yields what? Well, let's use E equals mc squared, where our mass is 1 kilogram. C, speed of light in a vacuum, 3 times 10 to the 8th meters per second, squared is just going to be 9 times 10 to the 16th joules. Answer number 4. A lot of energy from 1 kilogram of mass. Number 10. What total mass must be converted into energy to produce a gamma photon with an energy of 1.03 times 10 to the minus 13 joules? Well, if we're trying to get that energy, we know E equals mc squared. We want the mass, therefore mass is going to be equal to the energy divided by the speed of light squared, or 1.03 times 10 to the minus 13 joules divided by speed of light in a vacuum, 3 times 10 to the 8th meters per second, squared, which gives us a mass equal to about 1.14 times 10 to the minus 30 kilograms. Answer choice number 1. All right, 2 more here. A tritium nucleus is formed by combining 2 neutrons and a proton. The mass of this nucleus is 9.106 times 10 to the minus 3rd universal mass unit less than the combined mass of the particles from which it is formed. Approximately how much energy is released when this nucleus is formed? Well, excuse me. To do this, let's convert 9.106 times 10 to the minus 3rd universal mass units into mega electron volts, where I know that 1 universal mass unit is 931 MeV. Universal mass units are going to make a ratio of 1, and I'm going to end up with an answer of about 8.48 mega electron volts. Answer number 3. All right, last one on this page. After a uranium nucleus emits an alpha particle, the total mass of the new nucleus in the alpha particle is less than the mass of the original uranium nucleus. Explain what happens to the missing mass. Well, that missing mass must have been converted into energy. All right, if you struggled with this, it'd be a great time to go back and review the sections on nuclear physics. If this went well, terrific. Now you're probably ready to go tackle some of the AP level problems. Thanks so much for your time, everyone, and make it a great day.